Hello everyone, welcome back to another video on Dijkstra's algorithm. So in this video, we are going to find out the shortest distance between a pair of given vertices in an undirected graph as well as in a directed graph. That means graphs without direction and graphs with directions. Okay, so let's quickly get started with the very first case where given an undirected graph, we are going to find out the shortest distance between a pair of vertices using Dijkstra's algorithm. So this is the very first question that we are going to deal with. Given this graph, we need to find out the shortest distance between or the shortest path between B and G. That means from the vertex B, we need to travel to the vertex G and find out the shortest path. And obviously the weight corresponding to the shortest path. So the very first thing that we need to keep in our mind whenever we are using Dijkstra's algorithm, that we need to start this algorithm once we have removed all self loops present in the graph and we have removed all those parallels, keeping at least one edge and removing the remaining parallels having greater weights and keeping the one with the least weight. For example, in this graph that we can see, a to D vertex has a set of parallels. That means the edge having weight 8 and the edge having weight 2 are parallels in this case. And we are supposed to delete that particular edge which has higher weight. That means we are going to delete this edge which has weight 8 and keep that particular edge which has the least weight. So suppose in this case, if more than two parallels were present, if 3, 4, 5 parallels were present, we would have kept that particular edge which has the least weight and delete the remaining edges in that particular part. Okay, so the thing that we are going to delete in this case is the edge having the weight 8 joining A to D. To begin with Dijkstra's algorithm, we need to make a chart. It's easy to work with the chart, which looks something like this. Okay, and we are going to make that many number of columns in the chart as many number of vertices are present in the given graph. Okay, the number of rows that cannot be decided from beforehand, that we just have to keep on extending as the problem goes on. Okay, so here we are going to travel from B to the vertex G, and as I told you, we need to delete that particular parallel which has the greater weight. So in this case, we are going to delete this particular parallel. So I'll just directly delete it from the scene, and this is the graph that we are going to work with. Okay, so the very first rule is to just fill up the first row with the name of all the vertices that are present in the graph. So I can see I have vertices named from A to G and I have named them accordingly over here. Okay, now from wherever we are starting from the vertex B and we need to reach the vertex G. Okay, so from wherever we are starting, the starting point is B, we are going to allocate our value 0 and the remaining vertices we are going to assign infinity. Now, whenever we have completed one row, we are going to label that particular element which is the minimum value in that particular row. So in this row, the minimum value is 0. Now, how we are going to label it? We are going to label something by putting a box around it. And remember, whenever we put a box around a value for the first time, whenever we are putting a box for the very first time, we are going to somehow demarcate it. Okay, let's say I'll just put a tick beside it so that later on I can recognize that okay, in this particular row the element that was labeled was this 0 and not the other one. Okay, so this tick is just to recognize it for later on. Okay, now how we will proceed to the next row? This is the calculation that we need to do in your mind. Minimum of this labeled the previous value in a row. Okay, so I'll just write it this way: the minimum of previous value, comma, the weight, I'll explain what that is, plus previous label. Okay, so let's just try to remember this for now and let's see how this works out. So I have labeled B. That means right now I am sitting at the vertex B and traveling from B. Okay. So from B, I'm trying to travel to A. Okay, where I'm trying to fill up the A position. That means I am trying to travel from B to A. Now let's take a look at the graph. From B to A, the weight is 7. So the calculation that we are doing in our mind, this calculation that we are doing in our mind, I'll just write it over here, or maybe for the very first time I'll write it in the boxes. Later on I'll not write them. So the calculation that we are doing is minimum of the previous value means the value just above it. Okay, so the previous value, this value just above is infinity, comma, the weight plus the previous label. Now what's the weight? The weight is from B to A. From B to A, the weight is 7. So 7 plus the value of the previous label. The previous label is 0. So for this second row, whatever calculation I'm doing, the previous label, that value is fixed to be 0. For the next step, it's going to change. But for this particular row, the previous label is fixed to be 0. So the weight, which is 7, plus the previous label, which is 0. So 7 plus 0, that's 7. So now we are going to calculate the minimum of infinity comma 7. Okay, so the minimum of infinity comma 7, and I'll not write all this stuff over here. So that is nothing but simply 7. Okay, so I'll just maintain the color. So that's 7. Okay, the same calculation that we are going to repeat for the rest of the elements. But remember, whenever we have boxed something, that box is going to remain, and we are not going to do any calculation for that particular column. Okay, so whenever we box something, that means we label something, that label is going to continue throughout the column, and that's not going to change. Okay, so the box remains. Now coming to this particular element, which is C, in this cell, we are again traveling from B to C. We are traveling from B to C. The weight is 1. So minimum of, I'll write down minimum of previous value. Okay, so infinity, comma, weight is 1 plus previous previous label was 0. So the minimum of infinity, comma, 1 plus 0, that value is how much? It's 1. So I'll directly write 1. Okay. Next, if we proceed the same calculation, now we are going to do this mentally. Instead of writing so much, we'll just do them mentally. From B to D, okay, so from B to D, we can see that there is no direct connection. From B to D, no direct connection. So that means minimum of previous value, infinity, comma, weight. Now, what will be the weight when there is no direct connection? The weight we're going to consider is it as infinity. So the weight is infinity, plus the previous label. The previous label was how much? It's 0. So minimum of infinity, comma, infinity plus 0. So that's going to be how much? That's going to be infinity. So similarly, like this, if we try to fill up for this particular cell, for the cell E, we are going to have minimum of infinity, previous value, comma, B to E, there is no direct connection. So whenever there is no direct connection, we are going to take the minimum of previous value or infinity. Now in this case, the previous value is infinity. The weight is also infinity. So it remains unchanged. It remains infinity. Similarly, from B to F, no connection, infinity. B to G, no connection, infinity. Okay. Now, as I told you, the moment we complete one particular row, we are going to find out what is the least element in this row, excluding the labeled, the previously labeled value, excluding that. So excluding the 0, the new minimum is this one. So we are going to label this, and as I told you, the moment we label something for the very first time, I'm going to put a tick so that later on I can recognize it. Now again, moving on to the next row and just going along with this same calculation. Now again, remember, as I told you, something that is labeled, it's going to continue in the next column. It's not going to change. So this 0 and this 1, which were labeled from beforehand, this is going to remain as it is. It's not going to change. Okay, and we're going to do the calculation for the remaining cells. Now we have labeled 1, right? That means we have labeled the value in the C column, the one corresponding to C. So that means now we are traveling from C. Okay, so now you can just forget about B, whichever one you have labeled. That means for the first time in the previous row, that is the point from where you are starting your travel. So now we are traveling from C and trying to come to the column of A. That means from C we are trying to go to A. So again we'll repeat the calculation. So for the first time I'll write it. For the rest of the things I will not write it. minimum of previous value. As you can see, previous value is how much? It's 7. The previous value is 7. So previous value is 7, comma, weight. Now what's the weight from C to A? Okay, from C to A, the weight is 3. Okay, so weight is 3 plus the previous label. Now what's the previous label? The previous label is not 0 anymore. Now it's 1. So that means for this entire row of calculation, the previous label is going to remain as 1, not 0 anymore. So that's going to be 1. So now what's the calculation for this? Minimum of 7 comma 3 plus 1. So the minimum is 4. Okay. So I'll just fill this up with 4. Okay. Similarly, from C we're going to D. So from C to D, no direct connection. So the infinity is going to follow on. From C to E, there is a weight. The weight is 4. So minimum of previous value infinity, comma, weight from C to E, the weight is 4 plus the previous label. So 4 plus 1, that's 5. So that means minimum of infinity, comma, 5. So that's going to be simply 5. Okay. Now from C to F, the weight is 3. 3 plus previous label, which is 4. So minimum of infinity, comma, 4. So that's going to be 4. From C to G, no direct connection, so it remains as infinity. Okay. Now as we have completed a row, I told you we are going to find the minimum value in that row. Now you can see there are two minimums, 4 and 4. Assign anyone or label anyone you want, it doesn't matter. Okay. So let's say I am labeling this 4. Okay. And as I label it for the very first time, I put a tick beside it. So now I'm starting my travel from A. Okay. So now I am traveling from A and now going to the rest of the remaining cells. Okay. So whichever one I have put a label, I will fill them up. That's not going to change. So I fill them up and put a box around them. So these are not going to change. So we are starting our travel from A to D. Okay, so from A to D, the weight is how much? The weight is 2. So it's we are doing the calculation, minimum of infinity, comma, 2 plus previous label. Previous label is how much? Previous label is now 4. Okay, remember now the previous label is 4. So if you don't want to forget, just keep your hand like this 4. Whatever is the weight, add this 4 with it, so you will not forget. Okay. So the previous label is 4. 4 plus, we are going from A to D. From A to D, the weight is 2. So 4 plus 2, that's how much? That's simply 6. Okay. Then again, from A to E, the weight is 2. So 2 plus 4, that's 6. Now actually it's minimum of 5 comma 6. Okay. Minimum of previous value, which is 5, comma, weight, which is 2, plus the previous label, which is 4. So minimum of 5 comma 6. So that's going to remain as 5 and don't write it as 6. That's going to be wrong. Okay. Now from A to F, okay, we are traveling from A to F, no direct connection. So the previous value is going to remain. Minimum of 4 comma infinity is going to be, because there is no direct connection, so the weight is infinity. So minimum of previous value, comma infinity, previous value is 4. So 4 remains as it is. Now from A to G, okay, so from A to G, no direct connection, so infinity is going to remain as it is. And we have completed this row. We can see the minimum in this row is this 4, and we put a tick beside it, and we're going to fill it up for the next calculation. 1, 0, 4. Put a box around all of them and move on with our calculation. Now we are starting our travel from F. Okay, so now we are starting our travel from F. Now one question may arise in your mind: how long will I do this? Okay, we will do this until we reach G. That means until we have made a label in the G column. Okay, this process is going to continue until we have got a label in our G column. That means in our destination vertex. Okay, see, we have got a box in the label in the A column, B column, C column, F column. The moment we get a box in the G column, we are going to stop the problem over there, and from there we are going to try to figure out our answer. Okay, so now we are traveling from F to the vertex D. Okay, from F to D. So from F to D, there is a connection and the weight associated is 10. Okay, so from F to D the weight is 10. So minimum of previous value 6, comma the new value has a weight of 10, so obviously that's greater, so I'll just stick with the previous value which is 6 and not figure out the rest of the calculation. Then from F to E, the weight is 4 plus the previous label is again how much? The previous label is 4. So 4 plus 4, that's becoming 8, and the previous value is 5. So the previous value continues. Then from F to G, the weight is 7. The previous label value is 4. So 7 plus 4, that's 11. So previous value infinity, comma, weight 7 plus previous label 4. So the minimum value is 7 plus 4, that's 11. Okay, so as we have completed this row, we can see the minimum is this 5. We put a tick beside it and we continue our calculation. So I'm just going to label the ones that are already done before and not think about them. So the remaining ones are D and G. Okay, so now we are traveling from the E vertex. Okay, so now our travel is from E. From E we are going to D. Okay, so from E we are going to D. From E to D, the weight is how much? The weight is 1. Okay, and the previous label value is 5. So 1 plus 5, that's 6. And the previous value is also 6. So the minimum value remains 6. Okay, from E to G. Okay, so from E to G, the weight is how much? The weight is 2. And the previous label is how much? That's 5. So 5 plus 2, that's 7. Minimum of 11 comma 7. So that is 7. And we can see the minimum is the 6 value. So we label the 6, put a tick beside it, and carry forward with our calculation just like before. So now we are starting our travel from D. Okay, we have put a tick beside D. So we are starting our travel from D. From D, the only remaining cell is G. So from D to G, the weight is 2. The label is, previous label is 6. So 6 plus 2, that's 8. So minimum of previous value 7 comma 8. So that's going to remain as 7. And this is the only element remaining in this row. So we are bound to label it and put a tick beside it. Okay. So this is the place that we have figured out our entire chart of Dijkstra's algorithm. Now from here we are going to find out that what will be the shortest path. So to find out the path, we have to use a method called backtracking. Now just take a look how that works out. We are going to start from the final label that we have got over here. The final label is 7. From 7, we are going to move upwards until we find a change in the value. So from here, I move upwards. Do I find a change? The value remains same, it's 7. So if the value remains same, we keep on moving upwards. Now here I find a change. The value was 7. The value in this row is 11. So the moment we find a change, we stop over there. We take a turn and we go to that particular cell which has a tick in that particular row. So in this row, the tick is in this particular cell. So we directly come to this particular cell which has a tick. And again, we follow the same process. We start moving upwards until we find a change. So the value remains same over here. It's 5. We keep on moving up. We keep on moving up. We find a change, 5 to infinity. The moment we find a change, we stop and we go to that particular element which has a tick in that row. So we have a tick over here. So that's why I was giving the ticks so that later on I can easily recognize those values. So again, we'll follow the same process. We'll move up. There's a change of value. We stop and we go to the cell which has the tick. Okay. This process is called backtracking method. Now from here, observe how I will find the value. From B, the next particular vertex I have gone to, or I have changed my direction, is C, right? I have changed my direction. From B, I have gone to C. Okay, so from B, I have gone to C. From C, next I have changed my direction in which particular column? In the E column. Okay, so I have changed direction in E. That means from B, I have gone to C. From C, I have gone to E. Okay, from C, I have gone to E. And again, I have changed my direction in which row? In the row, sorry, in which column? In the G column. And that means from E, I have gone to G. Okay, so from E I have gone to G, and let's check the weights, corresponding weights. From B to C the weight was 1, from C to E the weight was 4, from E to G the weight was 2. So if we just add them, 1 plus 4, that's 5, 5 plus 2, that's 7, and that is exactly the same value that we had got over here, 7, right? So this is the weight corresponding to the shortest path. So what's the shortest path? B to C, C to E, E to G. And what's the weight? The weight is this particular last value that we had got, or you can find it this way also, 1 plus 4 plus 2, that's 7. Okay, so our path is B to C, and then from C to E, and from E to G. So this is our shortest path in this particular graph from the vertex B to the vertex G. Now the question is, if this graph was a directional graph, that means if the edges had directions, for example, if let's say the direction of this edge was something like this, okay, that means we are only allowed to go from E to C and we are not allowed to go from C to E. Then how would this be the shortest path? Then this will not be the shortest path in that particular case. This is an undirected graph, that means we can go in any direction along any given edge. But if the graph was directed, we have to go along the directions and not in the opposite direction. So if the direction of this particular edge was E to C and not C to E, then we couldn't have gone along this direction. Then what will be the mechanism to use Dijkstra's algorithm? So for that, let's use the same graph, just let's put some directions to it. So as you can see, I have put some directions in that very same graph, and we are going to follow Dijkstra's algorithm to find out the shortest path of this directed graph. And the question remains same. We are traveling from B to G and we want to find out the shortest path. So the very first rule remains same, that is, we need to remove any self loop or any parallels present. Now the question, is there any self loop? Obviously no. Everyone can see that there is no self loop in this graph. Now is there a parallel? Now some of you may think yes, there's a parallel. From A to D there's a parallel. No, this is not a parallel. These are having opposite directions. In directional graphs, if you have edges having opposite directions, they are not parallels. For these two edges to be parallels, both their directions had to be same. Both had to go either upwards or both had to go downwards. In that case, we could delete the edge having the higher weight associated with it. So in this case, we don't have any parallel in this graph and we have to deal with this graph and use Dijkstra's algorithm. So let's start. The starting part is the same. We are going to take down all the edges, the vertices that we have, which is A, B, C, D, E, F and G. Our starting point is B. So in B we are going to put a 0 and the rest of the values are going to be infinity. And we are going to box or label the 0, put a tick, and then proceed to the second row and keep the label for 0. Now for the rest of the things, we have to again use the same calculation, the same formula as before, just keeping in mind that whether we can go along that direction. If we cannot go along the direction, then we have to consider the weight to be infinity. What I'm trying to say is, let's say I have a connection from B to C, but I don't have a connection from C to B. In the previous case, B to C and C to B, both directions were connected, both were possible. In this case, B to C is possible, C to B is not possible. So if a situation arises that we are going from B to C, then the corresponding weight is going to be 1. But if a situation arises that we are going from C to B, then that's not possible. So the corresponding weight will be infinity and not 1. So if we are opposing the direction, then the weight is going to be infinity and not the particular one which is written over here. Okay, so let's see how that works out. So as you can see, I have labeled B, that means our starting point is B. So from B, the question is, can I go to A? From B, yes, I can go to A, the direction is allowing me. and the weight is how much? The weight is 7. So minimum of the same formula remains, minimum of previous value, which is infinity, comma, the weight is 7 plus the label, previous label, which is 0. So minimum of infinity, comma, 7 plus 0. So that's going to be simply 7. Okay. From B to C, again we are allowed to go. The weight is 1. So minimum of infinity, comma, 1 plus 0. That's going to be 1. Then from B we are not able to go to any other vertex, so the infinities are just going to remain as it is and nothing to bother about them. So in this particular row we can see the minimum value is 1, so we're going to label that, put a tick beside it and move on. So we we keep our labels intact and proceed with our calculation. Now we are starting from the vertex C. From C to A, we are allowed to go. The weight is 3. So minimum of 7, comma, 3 plus previous label, which is 1. So 3 plus 1, that's 4. So the minimum value is 4. Then from C to D, we have no edge connecting, so infinity remains. From C to E, we don't have, over here, keep in mind, we don't have a connection from C to E because the direction is opposite. So we're going to consider the weight as infinity and not 4. Okay, so minimum of previous value infinity, comma, the new weight, which is still infinity. So minimum of infinity, that remains as infinity. Now from C to F, that's possible to go. The direction is favoring us. The weight is 3. So 3 plus previous label, which is 4. 3 plus previous label is 1, so that is 4. Okay, so from C to G, that's not possible to go, so it remains infinity. The minimum in this row is again 4. We will assign this one. You can, if you want, you can assign that 4 also. It's not going to be any problem. So put a tick beside it, copy the labels that we have done from the previous row, and then proceed as before. So now we are traveling from A to D. From A to D, is it possible to go? Yes, it is possible. The weight associated is 8, not 2. Okay, from A to D, the weight associated is 8. Okay, so previous value, which is infinity, comma, the weight, which is 8, plus the previous label, which is 4. Okay, the previous label is how much? The previous label is 4. So 8 plus 4, that's 12. So the minimum value is how much? It's 12. Okay, now from A to E, we're going from A to E, that's possible to go. The weight is 2. So 4 plus 2, that's 6. Then from A to F, that's not possible to go. So minimum of infinity, comma, the weight is infinity. Sorry, minimum of previous value, which is 4, comma, the weight, which is infinity. So the minimum remains as 4 and not the infinity. From A to G, no connection. So it remains as infinity. So in this row, we can see this 4 is the minimum value. Put a tick beside it, copy down the labels and label them. Move on to the remaining empty cells. So now we are traveling from F to D. Okay, so from F to D, there is a connection. The connection is allowing us the direction. The weight is 10. Okay, so minimum of previous value 12, comma 10 plus previous label, which is 4. So minimum of 12, comma 10 plus 4, which is 14. So the minimum value is 12. Okay, then from F to E, we can go. The weight is 4. 4 plus previous label is 4. 4 plus 4 is 8, and the previous value is 6. So the previous value remains. Then from F to G, we are not allowed to go. So this still remains infinity, right? So in this particular row, we can see 6 is the minimum. So we put a tick beside it, copy the labels as before, and proceed as before. So now we are traveling from E to D. We are not allowed to go. From E to D, we are not allowed. So the previous value remains. From E to G, we are allowed to go. The weight is 2. So 2 plus previous label, which is 6. So 2 plus 6, that's 8. So the value is 8, and we can see this is the minimum. So our process stops right over here. We don't need this row. Okay, so our process stops here because, as I told you, the moment we get a label in our destination vertex, In the destination column, we stop right over there. Now again, just like before, we'll be using the backtracking method to find out the shortest path. Okay, so starting from the very last labeling that we have done, we'll move upwards until we find a change. In the very first step, we find a change, and as I told you, the moment we find a change, we change our direction and go to that particular cell which has a tick beside it. Then again start going upwards until we find a change. We find a change here, move on to that particular cell which has a tick, move up, there's a change, go to the cell which has a tick, move up, we get a change, go to the cell which has a tick. Okay, so this is how we have done our backtracking. Now let's try to figure out the path. From B, we have started from B, we have gone to which particular cell? We have gone to the column of C, so that means we have traveled from B to C. From C, we have changed our direction over here, which is in the vertex A. So from C, we have gone to A. From A, again we have changed our direction at E. So from A, we have gone to E. From A to E, again we have changed our direction at G. So from E, we have gone to G. And let's figure out what are the weights. From B to C, the weight is 1. So this is 1. From C to A, the weight is how much? It's 3. So that's 3. From A to E, the weight is 2. So that's 2. And from E to G, the weight is 2. So that's again 2. So the summation is 1 plus 3, that's 4, plus 2, 6, plus 2, 8. And as we can see, that is the exact same value that we have got over here. So this is our shortest path, and the weight associated with it is 8. So we have gone from B to C along the arrow, from C to A along the arrow, from A to E along the arrow, and finally from E to G. So that has been our shortest path in this graph from B to G using Dijkstra's algorithm, right? So I hope this video makes sense. If you have any queries, please let me know in the comment section. I'll try to answer them, and share this among your friends. Thank you. Have a nice day.